Hello and welcome everybody, I'm happy you guys are here. Let's dive into day number 3. And what's happening in here today is we are getting the information in, each line being a different rucksack. And the rucksack has exactly 2 compartments, which is always the same, or it fits always the same amount of items. Each item is represented by a different letter. And do bear in mind that uppercase and lowercase is an actual difference. So what's happening in here is that for each rucksack, we are dividing it in perfect middle to get those 2 compartments. And we are looking at one particular item that is repeated in both. Now the fun part is, all of those items has a corresponding priority to them. At the very end, we just find all of those repeated items and count the summary of their priorities. Alright, let's take a look at the code. But first, you probably noticed I already have sort of a rhythm to those challenges. So what I decided to change is use internals a little bit more, or rather use the access modifiers more. Why? Because I want my API of the solution to be clear and very simple to grasp. Perfect example in here, getPrioritySum is our main function and it uses findRepetitionItem. That findRepetitionItem is now internal because I don't want them to mess around with it unless they are sure of what they are doing. In order for that to work, we also need to do one more adjustment, which is give the permission for tests project to actually access those internals. You do add something like assembly info. If I were to comment it, our tests can no longer see half of those functions. So why do we need to test internals in the first place? This is the main test for that first part of day 3. We've got the input, which is 6 lines of coded items. We run the getPrioritySum, which is a public function, and we are expecting this exact number. But I also wanted to add tests that are a little bit more granular while writing the code. What I wanted to have is I wanted to be sure that the line is split in the middle, so I've got a test for that. And what I also wanted to emphasize and want to be sure of is for each line we do have that repeated item, so we can test that. So let's take a look at the solution itself. As I mentioned, this public function is what is actually important today. So it only accepts the text, which is a string. So we are looking at a separate line separately. What we achieve is the array of strings. Then we map to find that repetition item. And that repetition item, as you can probably remember, is the one particular character. It can be lowercase or uppercase, but it's one character. That's why from array of strings, we are going into array of characters. We map that character to its priority. So what we'll have in here is the array of integers, which represent the priority. At the end, last step is just sum those priorities up. That's it. Priorities values is something interesting, so let me just show you that. Alright, and the priority values, as you can remember, it's going from A to Z lowercase to have the priorities from 1 till 26, and then A to Z uppercase priorities 27 to 52. So if you mush those together, you get priorities from 1 to 52. And this is exactly what I did in here, 1 to 52. And those corresponds to letters. So I zipped the letters up. And the letters are quite simple, so this is also the array of lowercase letters and then the array of uppercase letters. So let test be that, and test then on its own is the dictionary, but the keys are the characters and the values are the priority. And I wanted to have it this way around because I'm always looking the data from the character. The character is my key. So, for example, if we want to have the priority of character, let's call it M, that's the priority, 39. Okay, let's take a look also at the find repetition item. This accepts text once more, so we split the line in half to have the first compartment and the second compartment. We push the first compartment into filtering of the string. So we're looking at the second compartment and checking if it contains letters from the first compartment. That way around, we'll find pretty soon whichever letter is the common part between those two compartments. And since this still produces a string, what we need in the very end is grab from that string the first letter or the first character. And since strings are actually sequence of characters, we can use sequence head for that. Part 2. We are looking actually at the same data, but we are looking at groups of 3. So if we are looking at 3 rucksacks, we are actually looking at 3 elves also, and we are finding the common item between those 3 lines or those 3 rucksacks. How does that change our code? Well, not much. As you can see, it's quite similar. So we get the text. Now we don't split it by new line because we don't want to do that. We want to split into into elf groups. We grab those 3 strings and we want to find only the character that is repeating in those 3, which is what getBatch function will do. Next, once again, we assign the priority values and just sum it up. Split text into elf groups. What does it do? We split the text through each and every line. We just trim the lines because that's useful. And then we use array chunk by size. And this is exactly what it does, right? It just grabs one array and just cuts it into equal parts or equal chunks, should I say. So what we'll return is the list of 3 lines, right? 3 lines, 3 lines, 3 lines, 3 lines, and so on. And this is actually quite nicely shown in the test. And where is it? Here it is. Okay, cool. So what we get in as an input is the 6th line, and what we expect in return is those 3 lines. And that's it. And getBatch is also quite fun. So what we're doing here, let's disregard the folding for a second. Once again, we get the text of 3 lines. So we once more split them up, we fold them, and that folding actually creates, or rather presents us once more and once similarly with repeated items or repeated letters. So what's happening in folding for common letter? We've got the accumulator and we are looking at one particular line. The accumulator starts as an empty string, so it actually lands in here right away. So it starts as an empty string, then we just return the line as a new accumulator. So we return line number 1. Let's take a quick example in here. So let's imagine our data looks like this. First of all, our accumulator is an empty line, and the line we are looking at is QWE. So we're running into this example, so we'll return the new accumulator as QWE. Oh, actually, I should have a common something in here, so let's call it that, and let's find E, right? So here we are running with the accumulator, with the new accumulator of QWE. Then the line is WES. Alright. And here is what will happen to it. So then we go into line number 22, right? And then we do the very same filtering as we did in find repetition item. So as we did in here. So that pretty much matches whatever is repeated in both of those. So the new accumulator will be actually WE. Our new accumulator is we. Our line is ZEC, apparently. So the new accumulator once again is the common part, and now the common part, there's no W in here, but there is an E, so we'll return the string that contains an E. And after we return that string in here, we just take the first character, since the string once again is actually a sequence of characters, we just get the first one. So let's see that in action. Yep, this is the outcome. Awesome. Thank you very much guys for paying attention. I hope you learned something or at least had a bit of fun. So let me summarize the changes I did. So first of all, I paid more attention into whatever is internal and whatever is actually public. I've added the assembly info, which doesn't have to be called that way, but this allows the testing project to access the internal functions of the solution project. One more change that I added today is I've added the link to my GitHub repo, so feel free to check it out if you want to play around with the code. That's the perfect opportunity, right? Just have fun yourself. If you have .NET installed, it will work quite nicely. Once again, thank you guys for paying attention and have a great day. And as always guys, we can do better as a pack. Bye. And that's pretty much it. Apart from that, it's straight up F#, straight up TDD, just writing tests and seeing them in action, and it all works out pretty great. Oh, I actually didn't show you guys the testing, right? So let's take a look at unit tests, and then we parameterize. Okay, we split text into ELF groups of 3.